Greetings. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Danish Aiman and this is my presentation for ocean ion fertilization. Question 1 regarding its understanding with two questions. History of ion hypothesis and area of ion fertilization. For the first OIC, for the first question, we have history of iron fertilization, which is we have the definition, the discovery in the ancient time, and how come Martins find them, and then the main objective of OIC. The definition of OIC. OIC is ocean iron fertilization, where the sea is climate change. So for the first definition is method of enhancing ocean productivity by adding iron to the nutrient-rich but poor nutrient-rich but iron-poor areas. So, which we have HNLC regions bracket. What is HNLC? HNLC is a high nutrient but low chlorophyll concentration. Therefore, therefore we add iron to nutrient-rich areas with low chlorophyll to stimulate photoplankton phytoplankton growth. So for the next is we aim to boost photosynthesis rate and help to draw atmospheric concentration as some of the carbon in phytoplankton eventually sinks to deeper ocean layers. Okay, so uh, the iron helps the iron helps phytoplankton to sequestrating the carbon by sinking to the deeper layer. Okay. Okay, so for the next slide is how they discover the composition of atmospheric gases in ancient time. Okay, first thing first, this experiment they are conducted in Antarctica and Greenland by analyzing the air bubble trap in the ice core, and the bubbles that are trapped are preserved, which allows we to analyze the atmospheric gases, uh, and also we can measure past levels of gases like CO2. For example, CO2, carbon dioxide, during the last glacial maximum was about 180 ppm part per meter cubic, much lower than the pre-industrial level of 280 ppm. Okay, so how did Martin come to this finding? Okay, so first, adding iron to high nutrient, low chlorophyll ocean regions can boost phytoplankton growth and therefore can help remove carbon dioxide from the atmosphere through carbon sequestration. Second, scientists conducted 13 artificial ocean iron fertilization experiments since the 1990s, mainly in the South Ocean and Equatorial Pacific. The studies show that iron addition could increase phytoplankton biomass, but the effectiveness of exporting carbon to deeper waters varied. So therefore, their success is dependent on factors like silicate availability, low grazing pressure, and repeated iron additions. Okay, so for the main objective of OIC is to add iron to regions with low iron but nutrient rich. They want to test out the Martin's finding, which Martin said that production of phytoplankton and a greater carbon sequestration can be done through addition of iron into the ocean. KIFES, or Korean Ocean Iron Fertilization Experiment in Southern Ocean, builds on past experiment by using multiple iron doses and longer observation periods to better track ocean responses. These studies also aim to monitor possible side effects like greenhouse gas release or harmful algal blooms. Okay, for area of iron fertilization, specify the area of iron fertilization in the world ocean and why are these areas have gained interest by scientists and industries. Okay, so mainly this area of iron fertilization focus on three HNLC region, which is Southern Ocean, Equatorial Pacific, and Subarctic North Pacific. Okay, so why are these gain interest by scientists? These areas are rich in nutrients but low in chlorophyll due to iron limitation, making them ideal for testing out by adding iron affects phytoplankton growth and carbon sequestration. Okay, for southern iron specifically important due to its role in deep water formation. For the equatorial Pacific, they help out the support for the iron hypothesis, while studies in the North Pacific have explored the impact of dust and grazing on phytoplankton. Okay, so these regions attract both scientific and industrial interest for their own potential in climate change mitigation, and also highlighting the importance of careful research to understand both benefits and risks. Okay, for the second question, OIC, importance of OIC, iron climate relationship. How does one low iron related to reduce carbon in atmosphere, vice versa? Okay, first we think of H and LC region. They are low in iron but high in nutrient. Okay, phytoplankton. Let's think of one diatoms. When we add iron in these regions, diatoms absorb it and then they grow more. When they grow more, they absorb more of carbon dioxide through photosynthesis. Therefore, they absorb carbon dioxide and then they sink into the ocean for a long time of period. But there are factors. There are factors that cause varied method in this. Those factors are grazing, fast decomposition, and short experiment duration. Some studies shows strong phytoplankton blooms, but limited of deep carbon export. Additionally, side effects like the release of greenhouse gas effects could offset benefits of this. OIC experiment. How many experiments have been performed so far to study OIF in the field? List several limitations that have been classified as potential causes for the unsuccessful finding of the study. Okay, since 1990s, there are 13 artificial iron of ocean iron fertilization AIOIF experiments have been carried out to test whether adding iron to HNLC regions could boost phytoplankton growth and enhance carbon sequestration. For the main limitation, we have other nutrient limitation. Example, gracia, silicate, zinc, cadmium, affected results. Even when iron was added, then we have short residence time of iron in the water due to sinking of mixing reduce its effectiveness. Sinking or mixing of its effectiveness. Then we have low light availability in deep mixed layers, limited phytoplankton ability to use the iron. Then we have high grazing pressure from zooplankton, which reduced phytoplankton biomass before it could sink. For the next, we have short experiment duration, which didn't capture full bloom and export cycles. And then we have measurement challenges, whereas such as inconsistent data from sediments, traps, and traces, which create uncertainty in carbon export estimates. Okay, so for this experiment, do they success or not? No, they have failed, but only affects European iron fertilization experiment have showed significant carbon export. But how? How can we? How can they improve? That is the third question. Okay, first we choose the right time and location. First we conduct the experiment in daily summer. Then we target areas like eddy centers with low grazing and high silicate levels to retain nutrients and reduce iron dispersal. Then we have extend experiment duration, which are we run experiment at least 40 days to capture the full phytoplankton bloom cycle and better evaluate carbon export. Then we have improved carbon export measurements by using neutral buoyant sediment traps and thorium T34 methods to measure carbon sinking at different depths. Then we monitor environmental side effects, watch for potential issues like greenhouse gas emissions and low oxygen zones and toxic algal blooms to minimize the risks. That's all from me. Thank you.